Hello students, welcome to the first section of online classes. Today we are going to learn the chapter 3 matrices. Chapter 3 matrices. It's already been started and done almost in class, but we'll just revise. If anyone has just missed or were not there, something. Now first, we need to know what is a matrix. What is a matrix? Matrix is nothing but rectangular arrangement of numbers or functions. The rectangular arrangement of numbers or functions. For example, consider this matrix. This matrix 139463. You put it in a square brackets, then it becomes a matrix. Put it in a square bracket, I repeat square bracket, and then it becomes a matrix. That is called as a matrix. Next we need to know what is the row and what is the column. So what is the row and what is the column? The horizontal section is called as the row, the vertical section is called as the column. If it is bent, it is a row. If it is straight, it is a column. If it is sleeping, it is a row. If it is standing, it is a column. So that is the row and the column. Now here you observe, there are how many rows? Now row is the horizontal, so bent section. So there is first row and second row. So there are two rows. Next columns is the standing one. So 1, 2, 3. So there are three columns. So there are how many rows? There are two rows and three columns. So that you need to recognize from a matrix. Next we come to the order of a matrix. Order of a matrix is nothing but M cross N. M cross N, where M stands for rows and N stands for columns. So how do you write the order of a matrix? So here, first we need to write the row. There are how many rows here? There are two rows. So write 2. Then cross. How many columns are there? There are 3 columns. So 2 cross 3. Got it? 2 cross 3. So M cross N, where M is the number of rows and N is the number of columns. So 2 cross 3. Next, we have learned about the order. Next, we will move on to the types of matrices. Types of matrices, there are various types. So the first type is the column matrix. So again from the name it's obvious. Column matrix is a matrix which has only one column. So this is the example for a column matrix 169, 169. So there are how many rows? There are 1, 2, 3. There are 3 rows and only one column. Next we move on to the next matrix, row matrix. What is a row matrix? Again, it's easy enough. Row matrix is a matrix which contains only one row. Example, so this matrix, there are how many rows? There is only one row. How many columns? There is 3 columns. So one row means it's a row matrix. Next we move on to another important matrix, square matrix. What is a square matrix? Square matrix is a matrix in which the number of rows equal to number of columns. The number of rows equal to number of columns. So here consider this matrix 139, 235, 149. So there are how many rows here? There are 1, 2, 3. There are 3 rows and 3 columns. So this is a square matrix. Next, we will take another matrix 2102. So there are 2 rows and 2 columns. So this is the square matrix. Now, when you talk about square matrix, we can write the order as 3 cross 3, or we can simply tell it's a square matrix of order 3. Since the number of rows equal to number of columns, since M equal to N. So we can write it as it's a square matrix of order N, or square matrix of order 3, or square matrix of order 2. Next we move on to the diagonal matrix. So first you need to know what is a diagonal. In a square, you know what's a diagonal? The crisp arc. Crisp arc is the diagonal. So if you consider this matrix, this part is the diagonal, the bent arc is the diagonal. It is the diagonal. So this is the diagonal. So what is a diagonal matrix? In a diagonal matrix, all the elements in the diagonal are not equal to 0. But all the non-diagonal elements are equal to 0. All the other non-diagonal elements are equal to 0. So all the other non-diagonal elements are equal to 0. Next we move on to scalar matrix. What is a scalar matrix? A scalar matrix is also a square matrix in which the diagonal elements, only the diagonal elements, are equal to a constant scalar k, are equal to a constant scalar k. So it can be any number, but it should be a constant scalar, and all the other non-diagonal elements are equal to 0. So what is a scalar matrix? Scalar matrix is a matrix in which the diagonal elements are equal to a constant k and rest all the elements are equal to 0. So this is a scalar matrix. Next we move on to the identity matrix. Identity matrix is a square matrix in which the diagonal elements are equal to 1 and rest all are equal to 0. The diagonal elements are equal to 1 and rest all are equal to 0. So that is nothing but the identity matrix. Next we move on to the zero matrix. Zero matrix, you know why it's a zero matrix. Zero matrix is a matrix, it's a square matrix in which all the elements are equal to 0. So it's a zero matrix because all the elements are equal to 0 and it should be a square matrix. So these are all square matrix, mind you. You need to remember all these are should be a square matrix. So they are defined as a square matrix. Okay. Yes. Okay. Next we move on to the next topic, equality of matrices. Equality of matrices. So you know what is equality? Two things are equal. We try to compare them. Now, when you try to compare them, they should be of the same type. Now, if you are comparing an apple, you have to compare an apple to another apple. You are comparing a banana. If you have to compare a banana to another banana. Now, you cannot compare an apple to a banana. So, when you are comparing matrices, the matrices, what is the first condition? The matrices should be of the equal order, of the same order. So, two matrices A and B are said to be equal if both A and B are of the same order. So, they should be of the same order. They should be of the same order. Same order in the sense M cross N. Rows and columns should be equal. Rows and columns should be equal. Next, their corresponding elements should be same. Corresponding elements means first element of first should be first element of second. So corresponding elements should be equal. I will give an example. Consider a matrix A 1 3 9 7. So matrix B 1 3 9 7. First you need to observe whether they are same order or not. What is the order of this matrix? There are 2 rows and 2 columns. So the order is 2 cross 2. Here the matrix B. What is the order? There are 2 rows and 2 columns. So 2 cross 2. So they are of the same order. First condition satisfied. Second condition is corresponding element. So here first element is 1, 1 equal to 1. Second element is 3, 3 equal to 3. Third element is 9, 9 equal to 9. Fourth element is 7, 7 equal to 7. So all the corresponding elements are equal. Therefore A equal to B. Therefore A equal to B. Next we see another example. Matrix C. C is 1 4 3 9. D is 1 4 0 3 9 1. Now matrix C 1 4 3 9. It is of the order 2 cross 2. There are 2 rows and 2 columns. Here this matrix is how many rows? There are 2 rows. Rows are equal, but the columns, there are 3 columns. So the order here is 2 cross 2. Here the order is 2 cross 3. So orders are different. Therefore they cannot be equal. So the matrices are not equal to each other. So C not equal to B. Okay. So this is about the equality of a